Dear friends, in the previous class we were discussing about what do you call it as real numbers. Is it right? We were discussing about real numbers. Now we shall continue the lesson with respect to that real numbers, and also we learned about how to mark irrational number, how to represent irrational numbers on the number line. Number line ಮೇಲೆ irrational numbers ನ ಹೇಗೆ ಮಾರ್ಕ್ ಮಾಡೋದು, ಯಾಕೆ irrational numbers ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ? We have seen that irrational numbers are neither terminating nor recurring. In that way, it is very difficult for us to represent or to give the position of that number on the real number. For that purpose, we have taken some geometrical way of representing real numbers or the irrational numbers on the number line. Today, we shall continue the lesson. Before that, we shall do a small prayer. Okay? Class, attention. 1 minute personal prayer. Break. Okay. So now let us see real numbers and their decimal expansion. Today we shall discuss about real numbers and their decimal expansion. Real numbers and their decimal expansion. Real numbers and their decimal expansion. So now let us take some real numbers. What are the real numbers? Let us take 3 by 2. It is a real number. That means it is a rational number. We have seen that. 7 by 8. It is a real number. That means it is a rational number. Or 8 by 7. We can consider reverse order. 7 by 8. Okay. 3 by 2. Real numbers and their decimal expansion. We have to convert that rational number into decimal number. Or we have to express that one in decimals. How do you do that one? Let us divide the numerator by the denominator. This is the numerator and this is the denominator. So now divide the numerator by the denominator. So what is that? 2 ones are 2. 2 ones are 2. Subtract. 1 is it the remainder? Put the decimal, take 0. How much? 2 5s are 10. So what is that? This is 1.5. 3 by 2 is the rational number or the real number. The decimal expansion of this real number is 1.5. Now take 7 and divide by 8. Is it? So what is that? Is it possible to write? No. 8 zeros are 0. 7. Put the decimal, take 0. How much? 8 8s are 64. Is it right? 10 minus 4. How much? 6. Now take 0. 60. How much now? 8 7s are 56. How much? 4 left. 8 5s are 0. 8 5s are 40. 7 8 zeros are 0. 7 minus 0 0. Put the decimal, take 0. ನಾನು ಮೊನ್ನೆ ಹಿಂದೆ ಹೇಳಿದೆ ಡೆಸಿಮಲ್ ಹಾಕಿದ್ರೆ ಯಾಕೆ 0 ತಗೋಬೇಕಂತ. Is it? So put the decimal, take 0. 8 8s are 64. 10 minus 4 is 6. Now take 0. 8 7s are 56. 10 minus 6 is 4. Now take 0. Is it right? 40. 8 5s are 40. What is its decimal expansion? 0.875. Now, what is the remainder? Remainder is 0. Here remainder is 0. When remainder is 0, we says that the division is completed. The division is completed. Is it right? So therefore, we can say that here 0.875. It is complete. It is closed here. There is no next digit. There is no next digit. So we say that it is terminates. Closed means the division is ends. The division is terminate. Is it? So therefore, if you see that this type of real numbers, we call it as rational numbers. In this type of real numbers, if you convert that one into decimal expansion, they terminates. The decimal expansion terminates. Is it right? So now we say terminating decimal. It is a terminating decimal. When we convert some of the real numbers into their decimal expansion, the decimal expansion terminates. The decimal expansion terminates. This is first case. Is it right? This is the first case. You see, what is that? First case is, take down. First case is when we convert some of the real numbers into their decimal expansion, comma, the decimal expansion terminates or ends after a finite number of steps. After a finite number of steps. Full stop. Here the remainder is 0. Here the remainder is 0. Such decimals are called terminating decimals. Such decimals are called terminating decimal. You take example. This is 1 and this is 2. This is 2. These are the examples. Over. Now let us take some other examples. Now take case B. Now take case B. What is that case B? Now take one more, what is called as real number 10 by 3. Is it? Take 10 by 3. It's a real number. Is it right? It's a real number. Now 10 by 3. Divide 10 by 3. 3 3s are 9. 1 left. Put the decimal, take 0. 3 3s are 9. 1 left. Take 0. 3 3s are 9. 1 left. Take 0. 3 3s are 9. 1 left. You see, the remainder continues to be as 1. You won't get 0. Now here, since you won't get the 0 in the remainder, we say that the division is not completed. The division is not completed. When division is not completed, now there are some numbers in the quotient. Now in the quotient, a number is repeating. What is that? 3 3 3. In the remainder also, 1 is repeating. In the quotient, 3 is repeating. So we write like this. This is 3.333, etc. Which is the digit repeating? The digit which is repeating will be expressed like this. 3.3 bar we says. The repeating consider the repeating digit and take one among them and put the bar. When you put the bar, that indicates that it is repeating. It is repeating. This repeating we call by another name called as recurring. It is recurring. Is it right? Now take one more example. 22 by 7. You take 22 by 7. Divide 22 by 7. 7 3s are 21. 1 left. Put the decimal, take 0. 7, how much? 1s are 7. Is it right? 3 left. You see 3 left. Take 0. 7 4s are 28. How much? 2 left. Is it right? 10 minus 8. 2 left. Take 0 again. How much? 7. 2s are 40. How much are? 6 left. Is it? 6 left. Which takes 6. 0. How much? 7. 8s are 56. How much left? 4 left. Is it? 4 left. 40. Yes. 7 5s are 35. 5 left. It is 50. So now it will be 50. So next 7 5s are 35. Look here. 7 5s are 35. 5 left. 50. How much? 7 7s are 49. How much? 1 left. 21. 1 ಎಲ್ಲಿ ಬಂದಿದೆ ನೋಡ್ಕೊಳ್ಳಿ. 1 ಎಲ್ಲಿ ಬಂದಿತ್ತು ನೋಡ್ಕೊಳ್ಳಿ. So 1 ಎಲ್ಲಿ ಬಂದಿತ್ತು? ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ರಿಮೈಂಡರ್ ಬಂದಿತ್ತಲ್ವಾ? ತಿರ್ಗಾ ಈ ಪ್ರೋಸೆಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಶುರು ಆಯ್ತು ನೋಡಿ. 7 1s are 7. 7 1s are 7. 3 left. It continues. The remainder again start to what? Repeat. So when remainders repeat, what will happen here? This complete decimal will repeat again. 3.142857. 142857. It goes on repeating. How many digits? 1 2 3 4 5 6. 3 digits are repeating. 3.142857. The complete number is repeating. Is it right? We call it as recurring. This type of what is called as decimal expansion, we call it as recurring decimals. Recurring decimals. Then what is the second case? The second case says that when we convert sum of the real numbers like this, sum of the real numbers, these are all rational numbers we are taking. You know that real number is a group of rational and irrational. We are taking rationals. So now what? When we convert some of the real numbers into their decimal expansion, the decimal expansion. So what will happen here? In the decimal expansion, do not ends. The decimal expansion do not ends but repeats. The decimal expansion do not ends but repeats. You see, repeats. This is called as, this type of decimal expansion we call it as recurring decimals. They are recurring decimals. Then what? This type of decimals are non-terminating recurring decimals. They are called as non-terminating recurring decimals. Take down second case, case 2, real numbers and their decimal expansion. The case 2 is B, right? When we convert some of the real numbers into their decimal expansion, the decimal expansion do not ends but repeats. The decimal expansion do not ends but repeats. Full stop. This type of decimal expansion is called non-terminating recurring decimals. 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 Okay, take some examples like this. 1 and then 2. ನಾನು ಯಾಕೆ 22/7 ತಗೊಂಡೆ ಅಂದರೆ 22/7 is a rational number because it is recurring decimal. But pi value ನಾವು ಯಾವಾಗಲೂ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ತಗೊಳ್ತಿರ್ತೀವಿ. Let pi is equal to 22/7. ಯಾಕಂದ್ರೆ ನಿಯರೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ pi is this is 3.1428 ಏನಿದೆ. This is the nearest value of pi. Hence we take the value of pi as 22/7. Is it? So take this as the examples. Now take case 3. What is that case 3? Let us take some real numbers, say irrational sum. These two A and B cases are rational numbers. What are rational numbers? The rational numbers are either terminating decimal or non-terminating recurring decimal. A rational number is either terminating decimal or non-terminating recurring decimal. Non-terminating recurring decimal. Is it right? So now take some irrational numbers. Just I will take one example, that is case 3. One is √2. Take find out the square root of 2. You know how to find the square root of 2 in 8th standard. 8th standard ಅಲ್ಲಿ square root of 2 ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ನೋಡಿದ್ರಿ. 2.0000 ನೋಡಿ ಈ 0 ಹಾಕೊಂಡು ಹೋಗಬಹುದು. Now first digit 2, its nearest square is 1. We write 1 ones are 1 like this. This is the method. 2 minus 1 1. Put the decimal. Here you are required to take 2 digits after the decimal at a time. ಒಂದು ಸಲ 2 ಡಿಜಿಟ್ ತಗೋಬೇಕು. ಈ ಡೆಸಿಮಲ್ ನ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡಿ take 2 zeros. Add this one here. Add this one. How much? Plus 1 like this 2. ಇಲ್ಲಿ ಏನು ಪ್ಲಸ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಆಡ್ ಮಾಡಬೇಕು 2. ನೋಡಿ 100 ಇದೆ. ಇದರ ಪಕ್ಕದಲ್ಲಿ ಒಂದು ನಂಬರ್ ಹಾಕಿದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಟೇಕ್ 5 ಹಾಕಿದ್ರೆ 25 ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಏನು ಡಿಜಿಟ್ ಹಾಕ್ತಿರೋ ಅದೇ ಡಿಜಿಟ್ ಇಲ್ಲಿ ಹಾಕಿ ಇದನ್ನ ಹಾಕಿ ಇದರಿಂದ ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಇಸ್ ಇಟ್ ರೈಟ್? ಈ ತರ ಬರ್ತದೆ. 2 ಇದೆ ಇಲ್ಲಿ. ಇದ್ರ ಪಕ್ಕ 5 ಹಾಕಿದ್ರೆ 5 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 25 5 125 it exceeds 100 ಇದೆ. ಹಾಗಾದ್ರೆ 5 ಅಂತ ಕಡಿಮೆ ಮಾಡಿ 24 into 4 4 4s are 16 100 4 2 8 plus 1 9. What's good? Now take 4 here 4. The product is 96. Take here subtract 10 minus 6 4. Here 9 minus 9 0. Now take this one add here plus 4. ಯಾವ ನೆಕ್ಸ್ಟ್ ನಂಬರ್ ಆಗ್ತದೆ ಅದನ್ನ ಆಡ್ ಮಾಡಬೇಕು. 4 plus 4 8 2. Here take next digit 2 digit 0 400. ನೋಡಿ ಇಲ್ಲಿ 1 ಹಾಕಿದ್ರೆ ಇಲ್ಲಿ 2 ಹಾಕಿದ್ರೆ 282 ಆಯಿತು. 282 2s are it exceeds 400. Take 1 here. ನೋಡಿ 1 ಹಾಕಿದ್ರೆ 1 1s are 1 1 8 1 1s are 1 1 8s are 8 1 4 2s are 2. 10 minus 1 how much? 10 minus 1 9 and here it is 9 minus 8 1. Here it is 3 3 minus 2 1 1 1 9. Is it? Now take next 2 zeros. Add here how much? This plus 1 plus 1 how much? 1 plus 1 2 get 2 like this. 11,900. Here it is 2,800. Here if I put 0 it will become 2,820. Is it right? Around you may say 3,000. How many 3,000 makes nearest to 11,000? 3 3s are 9 3 4s are 12 exits. You take 4 here. 4 ಹಾಕೊಂಡ್ರೆ ಎಷ್ಟು 11296. Subtract 10 minus 6. When you put 4 here, take 4 here also. Multiply this one by 4, you will get a product. Here it is the product. The product is 10 minus 6, 4. Here it is 9 minus 9, 0. 8 minus 2, 6, 0, 0. Nodi it continues. No repeats, no end at all. ನೀವು ಹಿಂಗೆ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ ಹೋಗ್ತಲೇ ಇರುತ್ತೆ ಹೊರತಾಗಿ no repeats, no end. Therefore what? So square root is 1.4142 ಹೀಗೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಕೇಸ್. Is it right? So ನೀವು 41 ರಿಪೀಟ್ ಆಗುತ್ತೆ ಅಂತ ನೀವು ನೆನೆಸ್ಬೋದು. ಹಾಗಾದ್ರೆ ಓಕೆ 1 ಡಿಜಿಟ್ ಮುಂದೆ ಮಾಡ್ಬಿಟ್ಟು ನೋಡೋಣ. 1 ಡಿಜಿಟ್ ಮಾಡೋಣ. ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ ಬಂದ್ರೆ ಕಷ್ಟ ಆಗುತ್ತೆ. Is it right? So like this. So what? 604 ಇದೆ ಇಲ್ಲಿ. ಇಲ್ಲಿ 604 ಇದೆ. So ಇಲ್ಲಿ ಎಷ್ಟಿದೆ? 2824 ಇದೆ. ನೆಕ್ಸ್ಟ್ zeros ತಗೊಳ್ಳಿ. ಇಲ್ಲಿಗೆ 4 ನ ಆಡ್ ಮಾಡಿ, 4 ನ ಕರ್ಕೊಂಡು ಆಡ್ ಮಾಡಿ 8 ಆಗುತ್ತೆ. 2828 ಆಯ್ತು. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ? 60400. 2828 ಅಂದ್ರೆ ಇಲ್ಲಿ 0 ಅಂತ ಬ್ರೇಕ್ ಆಗ್ಬಿಡುತ್ತೆ. 28000 ಆಗುತ್ತೆ. How many it makes? 60400. How many times? 28 ಅಂದ್ರೆ 2 ಹಾಕೋದಂತೆ ಜಾಸ್ತಿ ಆಗಲ್ಲ. 2 ಹಾಕೊಂಡ್ರೆ it will be like this 2 2s are 4, 2 8s are 16, 1 carry, 2 2s are 4 plus 1 5, 2 8s are 16, 1 carry, 2 2s are 4 plus 1 5. Subtract ಮಾಡಿದ್ರೆ how much it is? 10 minus 4 6, 9 minus 6 3. Here it is 13 minus 5 8. Here it is how much? Here it is it is ಇಲ್ಲಿಂದ ಬಾರ ಮಾಡಿದ್ರೆ 10 ಉಳ್ಕೊಂಡಿರುತ್ತೆ. 10 minus 6 4. It is 0 4836. Here 28000. Therefore it is how much? 4142 ನಾನು ಬರ್ದಿದ್ದೀನಿ. 4142 etc. It will continues that do not end. That is this type of decimal expansion we call it as irrational numbers are neither terminating nor recurring. So the third case is, what is that? Third case is neither repeats nor recur. They are called as irrational numbers. Now irrational numbers are also real numbers. You know, when we convert some of the real numbers, into their decimal expansion, in bracket irrational numbers, comma their decimal expansion neither terminate neither terminates nor recur. Comma neither terminate nor recur. Okay, so this is what is called as third case of irrational numbers. Example, you may take this one. So pi is also irrational number. Its value do not terminates nor recur. Its value is 3.14159263 etc. ಯಾವುದು ರಿಪೀಟ್ ಆಗಲ್ಲ, and in the same way. So like this. ಈ ತರ ಹಾಗಾದ್ರೆ ಜನರಲ್ ಆಗಿ ನಾವು irrational numbers ನ ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ? ಸೊ ನೋಡಿ ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬಿಡ್ತೀವಿ. sum of the values ಇದಾದ್ಮೇಲೆ third example irrational number is 3.10100. ನೋಡಿ ರಿಪೀಟ್ ಆಗಲ್ಲ ಅಂದ್ರೆ ಹೀಗೆ ಮಾಡ್ತೀವಿ. 10100 130 140 like this. ಈ ತರ ಬರ್ಕೊಂಡು ಹೋದ್ರೆ ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ irrational number. They do not end, they do not terminate, or they do not recur. Such we call it as irrational numbers. Okay, let us stop here. We shall take up some problems on this in the next class. Thank you very much. ಮಕ್ಕಳ ಬರಬೇಕು ಶಾಲೆಗೆ ಬಂದು ಏನು ಮಾಡಬೇಕು, ನೀವೇನಾದ್ರು ನೋಟ್ಸ್ ಬರ್ಸಿದ್ರೆ ಆ ನೋಟ್ಸ್ನ ತಂದು ನಿಮ್ಮ ಟೀಚರ್ಗೆ ಕೊಡಿ, ಕರೆಕ್ಷನ್ ಮಾಡಿಕೊಡ್ತಾರೆ. ಜೊತೆಗೆ ಬಂದು ಅಡ್ಮಿಷನ್ ಆಗಬೇಕು. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.